Hello world! This is a walkthrough video for Wax, which is an online audio synthesis environment that's based in the browser. So you can add different audio signal generators and processors together to synthesize sound. Here's a 440 Hertz triangle wave. There you go. So in this video, I'm just going to demonstrate the controls, show how it works, and hopefully make it clearer just how you can use this sort of thing. So the first thing you would probably want to do is to add a device to the workspace, and you can do that either by double clicking on the workspace and the autocomplete will show up. You can also type the letter N. You can also go to this devices drop down, and that's all the different devices. If you click one, it'll get added to the workspace. Then to create a connection, I'm going to do it here so we don't have to hear it. You can either click on the source and click on the destination and then double click on the connection to delete it, or you can have the connection highlighted and press delete, or you can drag to create the connection from either direction. So lots of different ways to create connections. I'm going to press the letter S, which adds a slider. Now I'm adding a smooth object so that there's not going to be any clickiness here. Connect the slider to the one operand of the multiply device, connect the triangle wave to the other, and now we should have a nice smooth amplitude modulation from the slider. So if you ever get confused or want to learn more about a particular object, you can click on the question mark and it will take you to documentation for that particular device. Here's the one for multiply, for example. So it takes you right to where you'd want to go. If you want to delete an object, you can just click that delete X. You can also select all of them and delete them that way. If you want to duplicate an object, you just have it highlighted and press Command D. So here's to duplicate 4 of them. So now I've got a whole bunch of noise. You can also do copy paste. So I've just copied those 8 and pasting them. And there you go. Now you've got 16 different noise generators, which I'll just go ahead and delete. Yeah, so some of the objects are generators, some of them are processors, some of them are kind of user interface elements that also produce signals. So everything in Wax is an audio signal, even if it's a user interface element such as this. And I'm going to add a scope so we can visualize what that looks like. Let's move this output over. So here's output X for the touchpad and output Y. So it's a two-dimensional touchpad, so you can move the X axis and you see one of the scopes is changing. Move the y-axis and the other scope is changing, so you can do both at the same time. And that can be really fun. This works with touch events on phones and things like that, so you should be able to have a lot of fun with like tactile control over the audio synthesis. And you can see the scope is helpful for just visualizing an audio signal. It also works, at audio rate, so I'll take that offset from this touchpad away, and it's just just noise. Cool. There's a bunch other helpful debugging objects. Here's a spectrogram. So since it's noise, it's just the entire spectrum is covered. And you can patch through them. So you see there's an input and output. So it's just helpful as you're figuring out what's going on in your patch. Another helpful device is print. And this visualizes your incoming audio. So if, say, for example, you have like a random and you've connected it to this clock. Clock runs once, it's basically a clock divider. So here, if I take n divided by 8, that would be 8 ticks in a second. So this is connecting to the trigger of the trigger inlet of the random object, which means that this will generate a random number between 0 and 127, 8 times per second. So then if I change the scope min and max to the same range as the random and then connect it, we should see showing those random values as they come in. You could patch that out to wherever you want. So scope, spectrogram, and print are super helpful for debugging and understanding what's going on in your patch. Also, just to note that if you connect 2 different connections to the same inlet, they just add together. So this should be both of them. And if I add another one, so let's go through the controls at the top. On-off just turns on and off the audio. Lock makes it so that if you have user interface elements in your patch, or really any device like just a triangle, for example. If you lock the patch, then you can't move it around. I'm trying to move it, it won't move. You can't delete, can't go to the README. So it's meant to just be something you can use for performance when you wouldn't want to have your patch messed up in some way. You can still change parameters here. And that's another thing, is that each device, most devices have inlets where that's for audio rate control. So you could connect another processor, another device, for example. Say I wanted to control this frequency with another audio signal, like a low frequency oscillation. So I'll start with a sine wave that has a range from -1 to 1, and let's say I want the output range to be from 2 to, I don't know, 120. And then I connect that to the frequency of this triangle wave, and just to make sure it's not going to be too loud, I'm going to multiply it by 0.25. Okay. So hopefully you hear that. If not, I can make this higher frequency here. So my point in bringing this up is that if I type into this parameter, since there's a signal connected to the same parameter here, basically the signal will take precedence, and this will not do anything until I disconnect the audio signal that's controlling the parameter. So I'll demonstrate what that looks like. Cool. Yep, so point being that audio rate connections, when there is both a text input and an audio inlet, the audio rate connections take precedence. Another cool thing to note about these text inputs is that they can accept either JavaScript or a live coding language that I've developed called Facet, which means that you can essentially have sort of randomized expressions. You can use code to specify what the number should be. So for example, if I wanted to randomly select the high, I could say a random integer between 200 and 1000. And then every time this regen button gets clicked, or every time a signal into the regen inlet goes above 0.5, it will regenerate that parameter. So let's connect that so we can hear it. So to demonstrate what that looks like when I connect to the regen inlet, turn this back up. So just as a simple example, the point being that these are kind of scriptable. You can live code them. Okay, so continuing on, if you want to save your patch, you can save it as a zip file, and that will include any audio files that you have included in your patch. So for example, there are some objects such as the play object where you can load an audio file. So I will do that. Go to my samples directory and add this 1234 file, and just to demonstrate what that sounds like. 1, 2, 3, 4. Okay, so let's save that. It just as the whatever name it comes up with by default. Then if I delete this and load my 1234, whoop, that was not the right patch. This is what I want. Okay. Then I click this again. 1, 2, 3, 4. And the audio buffer is back. Say I want to loop it and say I want to make the rate twice as fast.
1, 2, 3, 4. 1, 2.
Okay, so that's saved. Really helpful along with load for like storing your work, sharing it with other people, especially if it has audio files in it, because the share button allows you to share the state as a link, but it does not include any audio files because it just would be too much data to encrypt. So for example, if I have like a noise object and then a times object and a slider, and I connect them like this and I share it, it says the wax state successfully copied to clipboard. Note, audio files are not included in the URL and need to be shared separately. So yeah, just to note. Otherwise though, you can see this long string is now in the URL, and if I refresh my page, it will reload the noise and the slider connected together. So I'm going to skip the collab button for now. Essentially, it's a way to do real-time collaboration with other people where multiple people can be in the same session. There will be a separate video on that at some point. I already mentioned devices, and there's also a bunch of examples you can use to get started. So here's a list of basically zip files that are ready to load. So if I load the FM synthesis one, it loads this FM synthesis patch with some documentation on what is going on. And lastly, there's this about that is helpful, gives you a link if you want to go read more about the documentation. So that's a quick run through of how Wax works. One last thing to note is there is this kind of nested way to live code within Wax that's a little deeper than the just the simple sort of live coding that I've mentioned to this point, where you could do something inside the text input here. So there's a whole separate object called pattern, and the pattern object allows you to do live coding in Facet, which is an environment that's based in JavaScript that I've developed that allows you to generate patterns by chaining together various methods that generate and process data. And the documentation for Facet is online, but just to give a quick demonstration of the sorts of things you can do with it. So ultimately what happens is it's generating some data. So to do that, first you have to say _dot. That means create a new Facet pattern. And then we just chain together some methods. So let's say noise 16, generate 16 values of noise, and then scale that between 30 and 80. So that would be generate 16 random numbers between 30 and 80. And then let's put it into the key of D. And then let's translate that from MIDI notes to frequencies. So if I run control return, you see the command highlighted briefly. You can also hit control F to reformat it. And then if I add a little phaser in here, and you could run, you could do this with a slider or anything else, but it's basically wavetable synthesis. It's a lookup on a wavetable of numbers. So if I then just look at the values over here, I'm gonna scale this to like 0 to 1,000. I don't know exactly, but you can see that the wavetable of numbers, if I regenerate this, or say I like sort it, now it should be going up sorted. And then if I do palindrome, now you can see it's a palindrome. Now if I do echo 3, it'll be the palindrome but echoed. And these should still be like in the frequency range that you would use to sort of connect to an oscillator. So for example, if I do that and I connect it to an oscillator, and then I add some output channels, okay, so that is just a really quick demonstration of how you might use the pattern object for control structures, and allows you to sort of get that flexibility in your patch without needing to disconnect and reconnect a bunch of connections. You can also use the pattern object to synthesize sound itself. So not just like control rate information where there's only say 16 or 64 pieces of information that you're reading through with the phaser, but you can actually like generate full-on audio with this. So I don't know, just for example, I'm just going to type this Facet command that probably looks confusing, but if I run that and then I connect that to a phaser, this is just direct audio from the wavetable. Yeah, so just a simple example to show that you can also synthesize audio with this. Say, for example, you wanted to load a buffer. You could go to this, I'll go to the samples directory and just, I have this breakbeat that I use for testing a lot, so it's just called break.wave. It now, since I've loaded it into the browser with this buffer object, I can access it like this, and let's just hear how that sounds. Note that because it's reading it like a wavetable, it's at a different pitch than the initial break. So if you wanted to just hear the break itself at the pitch that it, correctly reading it at the correct pitch, you can use this trigger output instead. So every time a trigger gets received in here, it just plays back the audio inside the pattern at audio rate, at the correct sample rate. You could also try to find that by changing the phaser speed. So somewhere around there. So then let's rechunk it into 32 new sections where 50% of them have been rearranged. Cool. Yeah, so you can do some really fun stuff with any buffer that's been loaded into your patch, and do sort of audio sample-based live coding that way. There's also the ability to connect MIDI into Wax. So I'm going to just pull up from the examples a MIDI input patch to demonstrate that. So in this particular patch, which comes with the examples over here, this one's for MIDI input. And you can see that there are 8 different MIDI polyphony channels here that are all connected to 8 different sawtooths. And each of those voices, when they receive a MIDI note, they also send a little trigger out this gate. So essentially, whenever a note is received, it will go to one of the 8 sawtooths at the frequency of the note that was played and trigger this little amplitude envelope. And then all of that gets connected together into this single master gain output here, which is then basically going to the output after a low-pass filter, which is controlled by MIDI control change. So not only is MIDI note possible, MIDI control change is possible, there's also MIDI pitch bend, but I'm not going to demonstrate that here. So if I go to like Ableton Live, for example, so here I am playing some notes, right? And that's going through Wax. To demonstrate the MIDI CC, I'm going to just start Facet up real quick. So that I'm running just a simple control change ramp from 0 to 1 that'll kind of go like over the course of the loop, so that when I play, you can hear that is the low pass filter opening up, and to demonstrate that is being received. So that's just a MIDI control change coming from Facet. And you could obviously use this for tactile control and use it with like a MIDI keyboard and all that. A last thing to note on here is that the motion device, which you'll see here it's saying cannot connect to a sensor. That makes sense because I'm just on my laptop machine. But the motion device, if you use it on a phone or a tablet or some machine that has a motion sensor connected to it, like an inertial measurement unit, accelerometer, etc., then that data will be available as a control rate signal that you can use in your patch as well. So this makes it possible to do some interesting stuff where you're controlling things by moving your phone around in space. And I have had a lot of fun, particularly like a month or so ago, I conducted an audience of people where everyone loaded a prefab wax state that incorporated the motion device, and then I kind of asked everyone to follow along with my actions, and that was pretty cool. And then a last device that I wanted to mention is called input, and this allows you to access any microphone input. You can see that now it says microphone in use, so whatever the default audio input device is for your machine, you can access that in your wax patch and modify it in whatever way you want. Similarly, just to note that the output object also is the default audio output device for your computer. I'm not going to connect these directly because I think it would just be a feedback loop, but imagine, let's see, maybe I could do something like this and see what happens. No idea what this is going to sound like. Test. Okay, so since I'm using AirPods, I think if I'm down like this, you shouldn't hear. If I move it up, if I move it up, if I move it up, louder and 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 louder. Hopefully that worked. Okay, thank you for watching. Please feel free to reach out to me with any questions. I'm happy to answer them. And yeah, I hope you enjoyed. This is a free open source project that I did for graduate school. And yeah, just really grateful for anyone who uses it. I would love to hear how you've used it, what you've made with it. And thanks for watching. Bye.